Good afternoon, and thank you for joining us for the 18th webinar in the Offshore Wind series, Learning from the Experts. I'm Kate McClellan-Press, Senior Project Manager on NYSERDA's Environmental Research Team, and it is my pleasure to be joined by today's panel of experts, Carl Lobe with the Nature Conservancy, Dr. Annie Murphy with Inspire Environmental, Dr. Ido Sella with Eco Concrete, and Captain Dave Moni with No Fluke Fishing. Before I introduce our speakers, a few reminders for participants and some background on this webinar series. Next slide, please. First, if you are experiencing any technical issues, please contact Sal Graven at the email address on the bottom of this slide. This webinar is being recorded, and the recordings and presentation slides for all webinars in the Learning from the Experts series will be available on NYSERDA's website at the address on this slide. All participants have been muted. We will have time for questions and answers following this presentation, so please use the Q&A function to submit your questions for the speakers. Next slide, please. New York State is working to advance the responsible and cost-effective development of at least 9,000 megawatts of offshore wind by 2035. Offshore wind is a critical component in achieving the state's goals of 70% renewable sources of electricity by 2030 and 100% zero emissions electricity by 2040. While offshore wind has been providing clean energy to other parts of the world for several decades, this industry is brand new to New Yorkers. To provide interested stakeholders and members of the public with accessible, impartial information and opportunities for engagement on specific topics of interest, NYSERDA is hosting this educational webinar series called Learning from the Experts to connect the public with independent experts in key topics in offshore wind. We endeavor to select learning from the expert speakers based on their expertise, not necessarily for an alignment of opinions with NYSERDA or the state of New York. If you would like to suggest a topic or speaker for a future webinar, you can email us at offshore-wind@nyserda.ny.gov. Please note that the views and opinions expressed in this presentation are those of the presenters. Next slide, please. It's now my pleasure to introduce our panel. Carl Lobe is the Ocean Program Director for the Nature Conservancy in New York. Carl and his team focus on protecting and restoring marine surface water quality and estuarine habitats, improving the sustainability of marine fisheries, and on enabling coexistence of vulnerable and valuable ocean resources with existing and emerging human activities such as offshore wind energy development. Dr. Annie Murphy is an ecosystem ecologist with an interest in the interactions between human activities and energy flow in marine ecosystems. Specifically, her work centers on measuring changes in benthic functioning, such as biochemical cycling, in responses to human disturbance, such as shellfish aquaculture, offshore wind development, and coastal nutrient and organic inputs. Annie is a senior scientist at Inspire Environmental, a science-based consulting company focused on the use of sediment profile imaging and underwater video to characterize benthic ecosystems. Dr. Ido Sella, as CEO and Chief Scientist at EcoCrete Tech, specializing in reducing the ecological footprint of infrastructure in urban coastal settings while integrating principles of ecological engineering in the planning and construction of marine infrastructure. And finally, we are joined by Captain Dave Moni, who has been shell fishing, sailing, and powerboating all his life. Dave holds a master's captain's license and works as a charter fishing captain that often fishes recreationally around Block Island and in the Block Island wind farm area. Captain Dave Moni is also a writer contributing on fishing to various regional newspapers and blogs. Thank you all for joining us today, and I will hand it over to Carl to kick off the panel.
Thanks, Kate. I'm really excited about this panel. I think we have a really great lineup. As Kate mentioned, I'm Carl Lobe. I'm with the Nature Conservancy, and the Nature Conservancy fully supports New York State's ambitious climate change mitigation goals. And in my role as working in oceans, really overlaps with trying to achieve the offshore portion of that goal, which is critically important to achieving the overall goal in a way that is compatible with marine life. And to put the rest of this webinar into context, the Nature Conservancy has a strong background in habitat building and restoration on land and on the coast and in lakes and estuaries. But this offshore habitat is kind of a little bit of a new frontier for us and many others. I have some experience from my previous career working with the New York State Department of Environmental Conservation. I'm familiar with the artificial reef program, and I can tell you a lot of thought does go into where reef material gets placed when they're building artificial reefs, but the material is really material of opportunities, whether it's old ships or bridge material. And we were familiar with some of the work that's being done on what's called nature inclusive designs for both architecture of human communities and buildings in the Netherlands, and some recent work on translating those concepts of mimicking nature in architecture into the offshore wind space and thinking about how that could be done underwater. We also recognized that work that was being planned and discussed in the Netherlands wasn't necessarily specific to the habitats and the species here on the East Coast of the US, and how that could potentially be applied, what species and communities could potentially be affected. And we also wanted to produce a catalog of potential vendors and businesses that would be in the space who could help potentially supply some of these ideas should we be able to get some traction on them. We didn't have to think very long or hard for who we wanted to fold into early conversations about this. I'm suspecting some of the folks on this webinar are familiar with Drew Carey and his team at Inspire Environmental. They've been doing a lot of work around the Block Island wind farms and some of the other wind projects popping up and down the coast. And so we produced a bunch of materials that are going to be discussed, that you can access right on the, if you see that URL on the slide here at nature.org/turbine reefs, if after the webinar you want to kind of dig into some of this material. So I'm super excited about this panel and the discussion that's going to follow. The three panelists have different expertise and perspectives to bring to the conversation. And so with that, I want to turn it over to Dr. Annie Murphy, who is the lead author of the report that is on that website. Annie?
Great, thank you, Carl. And I'm very happy to be joining this webinar, and thank you for inviting me. I am a senior scientist at Inspire Environmental. I'm an ecosystem ecologist. I'm really interested in the flow of carbon through marine ecosystems. And by carbon, I mean energy flowing through ecosystems and how human activity can alter or influence that energy flow. And so today, I wanted to introduce you to the report that we pulled together and the catalog looking at the potential use of nature-based design within the context of offshore wind. Next slide, please. So as we all know, offshore wind development is expanding rapidly, particularly here on the US East Coast, where there's a substantial number of wind turbines being planned across these discrete lease areas shown on the map here. And all of these lease areas are under at various different stages of development and permitting. But we know that from studies from offshore wind farms in Europe, and also the turbines off Block Island and oil rigs really around the world, they tell us that novel structures that are introduced to the marine environment can serve as important substrate for benthic fauna to colonize. And this artificial reef effect has been documented really globally. And with this colonization comes shifts in both energy flow in the ecosystem and species distributions. And understanding the magnitude of these changes will help us to assess the regional effects of wind turbines in the marine ecosystem and how they may influence or affect connectivity across multiple scales. One of the largest changes to the ecosystem associated with offshore wind development is this addition of novel hard bottom habitat. And it can be valuable to various marine organisms and communities, including commercially important species. Next slide, please. And so with that in mind, we set out to explore the possibility of using nature-based design elements to potentially augment offshore wind habitat. So offshore wind developers typically lay down scour protection at the base of the turbine foundations. And this layer is usually composed of large rocks with the purpose of reducing scour around that novel structure. And using specific material that not only serves to reduce that scour, but also may increase complexity of the habitat, may increase the value of that habitat. So nature-based design products shown here, like reef balls and other products, typically aim to increase surface area by changing, different various size holes or various size rocks, increasing surface area, increasing physical niche space for organisms to live. And often that nature-based design products are composed of materials that tend to promote epifaunal growth, like a mixture of concrete with natural shell or calcium carbonate structures or products. So we produced a report that explored the idea of using this nature-based design concept out on the outer continental shelf, associated with scour protection layers as well as cable protection. Next slide, please. So one of the obvious concepts is that nature-based design typically is associated with coastal areas and coastal systems and has been tested and shown to increase habitat value in coastal systems. And usually within the context of habitat restoration, like oyster reef restoration, shoreline stabilization projects. And so there are some knowledge gaps with using this type of material out on the outer continental shelf within the context of offshore wind. So we outline those knowledge gaps in our report, namely, really can we augment and mimic natural habitat at these scour protection layers or these novel structures without deterring the purpose of those structures of scour protection. Again, exploring the idea that this is now offshore setting and no longer coastal. And so how does nature-based design products interact with the ecosystem and the trophic dynamics in that environmental context? And how, really how does local habitat distribution influence the colonization of these products? Is there an influence on native habitat, benthic habitat, on the colonization of these products and this novel structure? Next slide, please. So we outline some considerations that developers would hypothetically need to consider when thinking about the use of nature-based design within their engineering and within their project design. And the first foremost thing is to identify, why are we using, what are the specific goals that we're trying to accomplish when using nature-based design products? What are we aiming to achieve? And specifically, what target species do we find are valuable, and what are the goals? And those goals should be fed into the monitoring programs that are being developed. And those monitoring programs should be designed in a way to specifically evaluate the performance of of that nature-based design of that structure on the specific goals outlined previously. There's a lot of considerations like technical considerations, environmental considerations, logistical, clearly cost, and other users of the marine environment, fishing activities should be considered. Ecological context and the local community, the fish species that live there should be considered when designing these structures. And finally, risks. Clearly, we don't want to put material out there that's going to lead to structural failure or and the possibility of non-indigenous species colonizing these novel structures is a risk. Next slide, please. So the catalog that we pulled together includes nature-based design products that are currently available from US suppliers and that may have the potential to be used within the context of offshore wind. We sent a questionnaire to each supplier to collect information on the available product designs, any known ecological advantages, and where those were documented, in what environmental context, the intended use of the material, and the estimated costs. We've also included in the catalog and report a list of focal species with a focus on the current US Northeast wind lease areas, and we've included a list of species that have designated EFH essential fish habitat designations. We considered species with habitat preferences and geographic range that overlap with those current lease areas, species with high economic and ecological importance, and species that are considered sensitive to offshore wind development. Next slide, please. And this is just a screen grab of the nature-based design catalog, where each page is a different product. And we outline, we provide a product description, the ecological advantage documented in the literature, including publications associated with those studies, any specifications, and the product costs. So this is available on TNC's website, and I welcome you to have a look. And next slide. So yeah, I wanted to leave this up. We're really interested in exploring the concept of using nature-based design to augment the novel structures and the habitat that these novel structures are providing. And I'm looking forward to answering questions and the other panelists' thoughts. Thank you.
Thank you, Annie. So I'll proceed. My name is Ido Sella. I'm a marine biologist specializing in the impact of coastal marine infrastructure on local environment, focusing for many years on structure that are ranging from ports, marinas, seawalls to offshore installations. And in the last 10 years, focusing in a lot of R&D and also in terms of providing the market with practical solutions of how construction can be done in a more responsible way and reduce the impact on the natural environment, but maybe also gaining ecosystem services from the infrastructure itself, similar to the way that people are hoping to get from artificial reefs. Next slide. So just a little bit about e-concrete. E-concrete is an environmental concrete technology that complies with marine construction standards and provide biological and structural benefits. It means that its technology can be tweaked into the actual construction and allow the infrastructure to support biological targets in a better way and generate ecosystem services. Next, please. So maybe starting with why we focus on concrete. 70% of coastal infrastructure worldwide are concrete based, and usually concrete infrastructure are associated with poor biological performance. This is affecting the water quality nearby, which is something that it's not associated with offshore installation. Dominance of invasive species, and in general, low biodiversity. Next, please. This is where we apply our technology. So eConcrete is basically a technology that is complying with coastal and marine construction standards, but at the same time allowing the system to support biology. We do that in 3 different levels. The first one is addressing the composition of the concrete. The second is the microsurface at the micron level of the concrete, and the third one is more on a micro scale. And if we look at those 3 changes, they're addressing different stages in recruitment of sessile community. So addressing the chemical composition of the concrete, allowing us to neutralize the surface and allow more larvae and more organisms to settle on the juvenile phase and colonize the surface. And then the second and the third parts are addressing creating the micro niches, which is basically affecting survivorship, allowing them to mature and get to the reproduction phase. Next, please. So how do we apply that in terms of affecting the chemical property of the concrete? We do that with an admix that has been complying with the industry standards, that is added into the concrete mix, and the other application are done different technology that are usually associated with either the molding system or the way the concrete is cast on site. And next, please. And just to get a sense of the changes, so a concrete that is modified can actually provide a very unique and different support to the local environment. We're on average doubling biodiversity, significantly increasing water quality associated with the structure because of promoting filter feeders communities, creating an active carbon sink that is basically utilizing the surface of the concrete for that use, tilting the ratio between native and invasive species by allowing competition and opening the substrate for competition, allowing more species to settle on the concrete. That in a natural phase, you reduce the dominance of invasive species that are usually associated with concrete structures, increase species richness, and habitat creation. But how this is looking in practice? Next slide, please. So what you see here is basically the biogenic buildup and the growth of organisms on the same tile after 12 months. This is the same, more or less the same result that you can see from the Mediterranean to the mid-Atlantic, where organisms that are secreting calcium carbonate on the surface of the concrete, such as barnacles, oyster, tube worms, bryozoans, crawling algae, and others, are encapsulate the concrete with a calcitic layer, as we call it, the biogenic buildup. This biogenic buildup is creating a new habitat. It's starting to support other organisms, either motile organisms or boring organisms that can bore into the surface, and by doing that, increase the sessile community biodiversity that is affecting the motile community at the next phase. Next, please. We have more than 40 installations worldwide in different locations. As Annie mentioned, a lot of the information came from coastal and nearshore project, and what we're now doing is in the phase of implementing the same processes also for offshore installation. Next, please. So we started at the North Sea, working with a lot of work that was done in the Netherlands. We were a part of a project called the EcoScourer, run by Van Oord in the Netherlands, where different materials were evaluated for oyster spat recruitment. And you can see here In terms of an artificial substrate like concrete, modified concrete showed a significant better results in recruiting oyster spat than other materials that were tested. We actually got the same results working with the Billion Oyster Project in the US. Next, please. And we were very happy to be included at, in the technical report of the Nature Conservancy and Inspire, but at the same time, we see the same processes happening in other in parallel in other regions. We were also included in the Dutch government catalog for inclusive design for offshore application. You can see on the next slide. Now, a little bit of taking this into practicality. So I'll run really fast on project, because I think the best way to understand how the system can be applied is through actual project. So in the next slide, what you can see is the project was done and was finalized last year of a scar protection, of a shoreline protection system done with our articulated concrete mattresses, which is used both in near-shore application and also offshore application. This was done, a project installation was done in New Jersey, and what you can see in the next slide is basically 2 months after installation, how the biology is starting actually to creep up and develop on the concrete structure. This is including barnacles and bryozoans, different types of algae, and with them they bring and support also the motile community that is foraging on them. Next slide. Next slide. In the next slide, you can see the same product applying in offshore application. This is a project that happened the year before of armoring underwater cables that are running from a power station into the offshore with the same system. And in this case, a fully submerged application, again supporting the recruitment of the biology, and you can see that also on the next slide. And if we'll jump ahead a bit, on the next slide, you can see a large-scale application of the same system. So as we go into the offshore, requirements, structural requirements are changing. Also, the environmental requirements are changing. So in a way, systems need to target other environmental factors, such as making sure that it's not affected by sediment, movement and sediment. It's have the ability to release sediment and allow the surfaces to be exposed to colonization. So a different system. In this case, we started to use it and evaluate it on a project in the Netherlands of tow protection for a dike. And now we're applying the same system for offshore application, because you can see it on the next slide, where the system is used for protecting an underwater cable that was placed in a trench in Spain, and basically sealing it, securing it. Now, all the projects you see complying with the industry standards of either 60 years to 120 years design life, which is most of the project dealing that we deal with those days. In the next slide, you can see other application for offshore that we're dealing with. This is again a system, an armoring system based on e-concrete technology for a pipe, gas pipe that is crossing the Adriatic, and the system need to be protected from anchors and anti-trawling system. And the units were modified and designed according to the structural performance requirement, but at the same time have the ability to support target species and specific ecological targets that were specified in the process. And now I want to finalize a little bit with an R&D. So regarding a process that we're now dealing with, we were very privileged to obtain a grant from the Department of Energy in the US and the Bird Foundation for developing ecological scour for offshore application together with Holcim USA. And in this project, as you can see on the next slide, the idea is to comply completely with the industry requirements in terms of scar protection, application either on gravity-based structures or pile structures in terms of scar protecting, and comply with the industry requirements and the Northeast requirements. If you see in the next slide, installation is planned to start in May on 12-mile reef under the DEC controlled area, where 2 sites are going to be deployed. One of them with the new system, and the other one is a control site with a standard, mimicking a standard structure of scar protection, and both going to be compared in terms of ecological performance, production, stability, structural performance in a period of 2 years. The deployment is planned to be also in the same setup of the or similar setup to the actual conditions of the upcoming wind farm zone in the area, which means 120 feet water on a silty sandy bottom. And another project that you can see on the next slide is an RD that we're in the process, also going to be installed later this year, which is a mooring unit for floating turbines, high performance, large scale mooring unit, gravity based, where we apply our technology. So basically where we are going and working with the industry is in the area where the industry need to apply concrete, and then we can utilize this and reduce the ecological footprint of that structure, and also and harnessing it in general for providing ecosystem services. And with this, I'm going to conclude, and I'll be very happy to answer any questions later on. Thank you.
Let's go to the next slide. Yep.
Thank you, Doctor, and thank you, Dr. Murphy, as well. As a fisherman, my name's Dave Moni, and I'm a charter boat operator out of Wickford, Rhode Island. And as Kate mentioned in the introduction, I fish in Narragansett Bay, along the coastal shore of Rhode Island and parts of Massachusetts, and at the Block Island wind farm as well. So it's a pleasure to be here to share with you my experience fishing among giants, which if you haven't been there, they are so majestic, and I can't get within a couple of miles of them and from them, and charter customers want to go out to see the pylons and turbines spinning. So next slide, please. We can just skip this slide. Next one. So this is a winter flounder, and as you probably are aware, as a charter captain, I'm seeing a lot of changes on the water with my colleagues and other recreational fishermen, where the cold water fish like winter flounder are leaving coastal areas for deeper, cooler water. Because the water is warming. American lobster would be the very same thing. They've all moved up the coast north. And then we've had an influx, certainly, of warm water fish, such as scup, black sea bass, as well as summer flounder. But the thing that is remarkable, and that's been happening for the last 5 or 6 years, so we have actually tailored our business to those changes. What we're starting to tailor our business as well is to the influx of pelagic fish that haven't been here in mass before. Next slide, please. And these would be species, you can see this gentleman with a cobia. This gentleman caught this cobia on the surface in Rhode Island and thought he was hooking into striped bass. There was a school of fish schooling on the surface, and it was an actual school of cobia. This is highly unheard of in the environment of Rhode Island and in Massachusetts, but more and more we're catching cobia. Next slide, please. Bluefin tuna, arguably the bluefin tuna bite in the Block Island wind farm area and along our coast has been better than it has been in 20 years. And this was last year. We have these 2 young men who are anglers went bluefin tuna for the very first time with their dad, and actually caught fish, which is highly unusual, but very usual for last year in the year before. Next slide, please. And that would go through some more exotic species like mahi-mahi. We also have anglers. We have charter captains doing wahoo charters off Rhode Island. So these species are all becoming more and more common due to climate change. Next slide. And this brings us to the discussion of structure. As a charter captain and fisherman, I spend most of my time looking for structure, and that would be natural structure such as ledges, channel breaks, deep holes, rock clusters, banks, or man-made structure such as bridge abutments, jetties, ocean platforms, artificial reefs. So we're constantly looking for structure and fishing for structure. And I know of no structure in my experience that has been bad for fishing, natural or man-made. Next, please. And that brings us to the fishing in the Block Island Wind Farm area. Here you can see the charter vessel Necessity out of Wickford, Rhode Island, trolling in the Block Island Wind Farm this summer. In what really is happening, may I have the next slide, please? You can see this is a screen grab of a video taken at the base of the Block Island Wind Farm. And you can see the mussel growth. You can see smaller fish feeding around the structure, such as black sea bass and scup. And then circling the perimeter, we have larger species, such as striped bass and bluefish. In fact, we have divers. I'm a member of the Rhode Island Saltwater Anglers, and we have a whole diving club. They dive on the turbines to spear fish for large striped bass. We also have, what's developed now is we have a lot of charter captains and anglers who are actually fishing the turbines for striped bass, really uptight close, dropping eels down and catching large fish, large striped bass. Next, please. You can see the Block Island Wind Farm. You can see the 5 turbines located in that yellow area. And historically, north of the turbines, that's actual Block Island, the south side of it. So between the turbines and the island, historically, that has been a very good fishing area for striped bass, for summer flounder and black sea bass, and it really still is. The area on the other side of the turbines, which would be south of them, there's a lot of humps and bumps in that area. Cod fishing historically has been pretty good. And I'd like to share that on the left-hand side, which would be the southwest side of Block Island, where you see that red can out to the 3-mile limit. You can see the 3-mile circle. That area historically has been very good for striped bass fishing, as to the south side of the island, between the Block Island Wind Farm and the southeast side of that island. So next slide. You could see here's Captain Paul Eidman from New Jersey fishing the Block Island Wind Farm. These are obviously black sea bass. Next, please. You can see black sea bass and summer flounder caught right in the Block Island Wind Farm area. They may not have been caught right on the turbines, but certainly within a half mile of them. Next, please. Commercial rod and reel fishermen catching summer flounder, both north and south of the turbines. By the way, as you're probably aware, in the Block Island Wind Farm, there's a lot of fixed gear. There's a lot of commercial fishermen. There are gill nets, there are lobster pots, and all of this fixed gear is set right up to the wind farm area. Next, please. And you can see this was actually this summer. You can see at the very top of this slide, the Block Island Wind Farm. This is the Block Island Inshore Fishing Tournament, which took place this year. And this was the second winning team. And you can see they've caught fluke, black sea bass, and actual bluefin tuna, not necessarily right in the wind farm area this day. It might have been, a half mile to a mile away. Next, please. Cod fishing, as I mentioned, cod fishing is good some years and bad some years. This year it's been a kind of a soft year, but these fish were caught right in the Block Island Wind Farm area, just south of the wind farm. Next, please. And traditionally, even though the wind farm has been there 7 years, things are maturing now, but the places that have historically had fish, like the southwest ledge, are still bearing fruit. And you can see a nice striped bass that was caught there this summer. Next, please. And this again was on the southwest ledge. This was the winning bluefish of that tournament that I mentioned earlier, a 36-inch bluefish. By the way, that's John O'Keefe, who used to be with Deepwater Wind in Orsted, that was on my boat fishing that tournament. And it was a great bluefish. I think, as I said, it was 35, 36 inches. Next, please. So all of this fishing occurs in historical places. Block Island has been a great place to fish for many, many years. It still is. Historically, the places that have been good are still good for those species. In the Block Island Wind Farm, right at the turbines, the fishing is great for black sea bass and scup. Now that it's matured, we're having anglers target it for large striped bass by dropping bait and eels down. There's been more pelagic fish. There's been more bluefish right in the Block Island Wind Farm. A lot of mammals in the Block Island Wind Farm as well the last couple of years. Next, please. So I say this in spite of enhanced fishing pressure at the Block Island Wind Farm. Before the wind farm was there might have been 25 boats on a summer day fishing the south side of Block Island in that area. Now there are 100 boats some days, or 50 boats, or 75, depending upon the day of the week. To my knowledge, and I try to follow this as a fishing journalist, the southern New England offshore wind energy science formed as far back as 2017, after a couple of years of the wind farm was in existence. There were about 25 studies reviewed at that forum: acoustics, habitat, trawl surveys, etc. And there were no remarkable adverse effects on environment, fish, mammals, or birds, or people, long-term effects. So the Block Island Wind Farm has been good for fishing. Next, please. In that forum, they cautioned everyone about cumulative impacts. And as a charter captain who fishes the Block Island Wind Farm specifically, I'm very encouraged by future wind farms bearing fruit, creating habitat, and creating fish. And I say that there will be hopefully a cumulative positive impact on fishing. I know my brothers and sister charter captains in New York, Captain John McMurray being one of those out in New York, can't wait for the offshore wind farms to be built in the area. The habitat there is basically mud in the areas where he is fishing, and he's hoping that structure will be there. So we're 7 years out at the Block Island Wind Farm. It's still bearing fruit in spite of 300% enhanced fishing pressure. Habitat has been created, life has been created. It's attracting fish of all sizes. All of those fish we love to catch, eat, and release. Next one. Slide, please. I think offshore wind and fishing can coexist. This is a perfect example of Ido and Annie speaking about enhancing structure at the base of pylons. I think it would be great. The Block Island Wind Farm is actually proof that it works. There's enhanced structure. I think conducting fish and habitat research, and Annie mentioned this, of surveying how those new habitats are doing. Of course, good research and monitoring plans before, during, and after construction are very important. And we have a proven protocol that was used at the Block Island Wind Farm research and monitoring plans. And I think with enhanced habitat and the things that we're exploring, I think that's going to have a greater positive impact. Next, please. And that's all I have. Fishing among giants. I can't look forward to that opportunity moving forward. So thank you. And I think it's back to Carl.
Yeah, sure. And if everyone can turn their cameras on, we got a bunch of questions coming in. And I actually want to start with Annie. Annie, one of your slides mentioned the Rigs to Reef program. I think it was next to something about decommissioning, and I just wonder if you could speak to any lessons learned from that program, and maybe even it's some monitoring if you have ideas about what could be learned about pros and cons about different kinds of decommissioning. And I think that's where the Rigs to Reef program really was at, right?
Yeah, sure. Yeah, so the Rigs to Reef program in the Gulf of Mexico is really aimed at supporting and encouraging the reuse of oil platforms instead of decommissioning them, but using them in the development of artificial reefs. So rather than requiring the developer to decommission that structure and remove all the materials from the ocean, but use it as an artificial reef moving forward. So it's a useful concept, and I think it applies well with other artificial structures like offshore wind structures. I think it needs to be carefully targeted. So we need to understand how that habitat, that novel hard structure habitat, is functioning, and account for that added value, if there's added value, before determining whether we should decommission it or not. There's a recently published review on the Rigs to Reef program in the ICES journal, Fortune and Patterson, and they really outline the need to use science to inform policy and not just have this blanket policy of decommissioning all artificial materials from the ocean, but understanding how that structure is increasing secondary production at the lower trophic levels. We know that it's promoting secondary production. Filter feeders are colonizing those structures, high diversity of epifaunal organisms. And the next question is, does that increased secondary production at the base of the food web increase or lead to increased secondary production at higher trophic levels, like what Captain Monty was talking about, increased fish productivity? And there are new technologies to document and monitor hard bottom structure, the use of underwater imagery, the use of photogrammetry to really get at the increase in biomass over time, as well as identifying with non-extractive approaches, identifying the organisms living there and how they may be functioning and changing the ecosystem.
Thanks,
Yeah.
Annie. I wonder along those lines, and maybe this is for both you and Dave, clearly there's going to be recreational and commercial fishing happening near these turbines as a permissible use. Everyone's expecting it. Does that create obstacles or opportunities perhaps for collaborative research, or does it complicate monitoring, or are there ways to work with perhaps maybe work with the fishing industry? How are you guys viewing that? Both of you, maybe.
Annie, I'll just jump in. I know that both the commercial, and I think this is what you're getting at, Carl. I know that both commercial, the for-hire industry, and private anglers have been tapped to do wind farm research. The recreational private anglers are particularly helpful when rod and reel studies are necessary. And there have been a couple. In fact, I think Annie's group, Inspire, facilitated one such study. And I know certainly that commercial fishermen have participated in wind farm research as well. And I know the for-hire industry has done that by being the vessels that the private anglers take under a controlled environment with scientists on board doing that research. I don't know if that's what you were asking or not, Carl. I think the coordination of that and its impact on that new habitat that's being created, maybe Annie could address that. I'm not quite sure.
Yeah, I think it poses a great opportunity for science and the people that really know the ecosystem very well, the fishermen, to collaborate and using that knowledge of the fishermen to design studies that make sense for that local environment and that local ecosystem, and you know, having them participate and inform how data are collected, and that just makes perfect sense and should be the way things are done. And that's how, you know, Block Island Wind Farm projects were conducted in close collaboration with the local fishermen and that community.
Great. Ido, you mentioned some projects that eConcrete's doing with wind developers, and I'm sure there's some on the webinar now, and I'm just wondering, you know, if they were interested in what's really the right time to start thinking about incorporating these designs. What phase in the planning process is kind of most effective from where you sit?
So yeah, maybe before that, maybe a note about the rig to reef and the decommissioning. I think what there is a major difference between the rig to reef that we saw until now, that was mostly addressing gas and oil infrastructure, that is placed on a certain time for a certain time until the resources are not available anymore and need to be decommissioned. And then there's the issue of the environment that they create and the impact on and either to use it and the ecological value of those structures that are introduced into the site. I think it's the discussion regarding wind farm is a bit different, and the reason is because the area that the wind energy farms are gonna be located is probably gonna be there for a very long time, and the technology might change. By the infrastructure that supports the transfer of energy from the site to the shore, and the impact, specifically the scour, the impact that is happening on the bottom, probably more or less going to be the same, stay for a longer time, and because the resource is an endless resource, and the site has already been built for supporting that. So just the technology probably going to change with time, which means that the impact on the environment is more on a long term. And because of that, we need to think about succession processes and how we address them and how we support those specific targets in an area and that probably going to be more or less stable in terms of the change that happened on it. Now, regarding how the changes need to be incorporated, the first and the most important is that those structures are not there as an artificial reef. They have a target. They have a structural target that they need to comply with, and they have liability issues and requirements that need to comply. And it's starting from the filter layer to the size of the scar to how the units are built. So first of all, everything needs to comply with the requirements of the engineering team and those things. And then once the targets are known and the size of the unit or the infrastructure is already in more or less in a phase that we know where this is heading, I think this is the place to start to integrate ecological design that need to comply with the structural performance. So that's when you know the size of the rocks. That's when you know the size of the the volume that needs to support, the density, the longevity that they're aiming for, is like for how long they're planning the infrastructure. So I think it's not very initially in the process. It's after the concept is already set, and more or less there is a line of design that is dictated by the engineering team.
Great. That's really, I think, useful for lots of folks to know.
Ido, maybe a follow-up question on what you need to know ahead of the installation process for what kind of oceanographic or ecological factors do you need to consider ahead of time, and how do you get that data and information? How is it being measured at these places now? So what kinds of things do you need to think about before that installation might take place?
So first of all, it's a lot of baseline surveys. So you take the geotechnical information that is usually arriving from the engineering team, which will provide us the information about the stability of the structure. Do we predict there's going to be, for example, sand waves that are going to cover it for a certain time? What is the height that we predict those sand waves will affect? If there's going to be some settling of the system. Now, there's always the balance. We want to create a habitat. We want to increase the biodiversity of the Sessa community. We need to make sure that we allow them the condition to do that. And a part of it is making sure that we are not accumulating sediment, not clogging the system with sediment, allowing the spaces and the opening that we want to create in order to facilitate the target species. So we're starting with a set of baseline surveys, then deciding what are the target species for that specific installation. And sometimes supporting the target species is not actually supporting the target species, it's supporting the organism that they forage on. So it's not just facilitating the size of the holes and providing, but looking at the food chain, understanding what are the organisms that need to be there in order to support that specific species, if it's a target species or a target biological community. And this can be done. And a lot of the information is before, and a lot of the information is also included in any project this size in the EIS process. So this is a great source for working with.
Ido, there's another question coming in for you about structural testing of the concrete material that you make, and how is there testing that goes along with that, or maybe how does it compare with other concrete structures?
In terms of structural performance, it needs to comply with exactly the same requirements of any standard concrete. Compression forces, tensile forces, abrasion forces, freeze and thaw, which is an issue that in coastal area that need to be addressed. There's no change. The structural requirements will not change. You need any engineering, ecological engineering, need to comply with those requirements, and it's very important. And that any technology that is out there will be able to provide that and be in a way that will comply with the design lifetime, the extreme events. And basically is working with what are the standard requirements in terms of structural performance, and make sure that anything we bring into the table will comply with those design standards.
Kate, did you have anything else?
I think this question, maybe we're going back to Annie for a moment. Can you talk about in places around the world where they have developed artificial reefs or incorporated nature-based designs into offshore wind or other activities, and they have focused on specific fishery species? Is there information about the ecological, fisheries, or socioeconomic effects on targeted species versus the non-targeted species that the U.S. could learn from?
Let's see, nothing really pops into my mind. It's going to depend on the environment and the species there. We know that there are mobile species, fish that prefer structure, and there's fish that are more pelagic and don't require as much structure. There is this constant debate about whether that structure is just an aggregating device, or whether it's actually being used, that increase in prey availability is being used by the mobile fish and increasing their production. And that often, and there's studies that show that yes, fish production increases with more structure, and there's studies that show that it doesn't, and it's really just an aggregating device. and those fish would exist without that structure being there, but in less of a dense area. So I don't know if I'm actually answering your question. But
no, it's okay. I think one of the messages is there's a whole lot more work that needs to be done to understand this in the context of the United States, and some really exciting work potentially underway. And our hour has flown by. I just want to thank everyone for joining us for this Learning from the Experts webinar. And a reminder that the recording of this and the presentation slides will be available at nyserda.ny.gov on the Offshore Wind series. And the next webinar in the series is on March 2nd at 1:30 p.m., slight change. Carrie Cullen-Hitt with the National Offshore Wind Research and Development Consortium will be speaking about the research priorities around offshore wind. And you can register for future webinars through our events page at wind.ny.gov. And if you have any requests for future topics you would like to hear about in this series, please email us at offshorewind@nyserda.ny.gov. Again, thank you for joining us today, and see you next time.